Hi everyone, today I'm going to talk about a problem called is graph bipartite? So if you want to know the best resources to get into a top tech company, I have a video in the description below that will tell you the best books, the best problems that will save you time and save you money, because time is money. So let's take a look at the problem. Is graph bipartite? So this problem is pretty cool. So basically you're given a graph and you have to paint each node of the graph with alternating colors. So one node has a white color, the other one is black, and you alternate. If for some reason you have two adjacent nodes that have the same color, the graph is not bipartite. So the way we're gonna do this is we're gonna traverse the array. So the way the graph is represented in this problem, so this is a LeetCode problem. So the way it's represented on LeetCode is a 2D array, and what you have is each index is equivalent to the node. So index 0 is node 0, index 1 is node 1, and the elements inside of the array at index 0 are the nodes that 0 is connected to. Let's actually take a look at that, so it's easier if you guys see the problem. So let me share my screen with the problem. So if you look at the problem definition here, you will see that node 0 is connected to 2 and 3. So node 0, 1, and 3. So node 0, because it's in the index 0, is connected to 1 and 3. Index 1, so this one is connected to 0 and 2. Index 2 to 1 and 3. 1 and 3. Index 3, 0, 2. So this, for example, just by inspection is bipartite. This one is not bipartite. So what I did is I put those two graphs on VS Code, and we're going to explore the code. So what we're going to do is we're going to do DFS. So here we're exploring all the nodes. And on DFS, we're going to explore the neighbors. If one of the neighbors is already in the hash map, we're going to check if the color is the same. If the color is the same, it means that the current node and one of its neighbors have the same color. And by definition of a bipartite graph, will return false. If it's not in the hash map, if one of the neighbors is not in the hash map, we're going to put the opposite color. How is this going to create the opposite color? If the color of the current node is 0, 1 minus 0, 1. So that's the opposite of 1. The current node's color is 1, 1 minus 1, 0. So this technique here, we get the inverted color of the current node. And we recursively call DFS on one of its neighbors. If we iterated through all the neighbors and we didn't get same color at some point, we return true, meaning the graph is bipartite. So let's put a breakpoint here. So we'll start with graph 1. So let's stop the debugger and we're gonna run the code with the debugger. So we come here, we stop before the function call. So here we have graph 1, graph 2. Let's stop here. So now my color hash map is empty. My I equals 0, so we'll start at index 0, which has neighbors 1 and 3. And we're gonna call DFS. So now we're gonna loop through the neighbors of 0, which are 1 and 3. So we'll start with 1. 1 is not currently in my colors array, so what we're gonna do is put 1 in the colors array with the opposite color of 0, which is 1, and explore now 1, which has neighbors 0 and 2. So now we're gonna explore the neighbors of 1, which are 0 and 2. 0 is already there. but 0 is not the same color, so now we'll look at 1. So now we'll look at 1. And no, at 2. So now, because it's the second neighbor, so now we're gonna explore the neighbors of 2, which are 1 and 3. 1 is in the hash map, but since it's not the opposite of 2, we continue. And then we put 3. And we keep on going. So that's the first example, and that's the example where we don't have, where the graph is bipartite. So if I continue the program, we'll eventually have a hash map which have alternating colors. So the colors are represented in the hash map, so we return true. But if we did with graph 2, that would return false. So let's actually try that out. I'll put a breakpoint here. So let's run this. Let me call with graph 2. That's why it's not stopping there. So now on graph 2, observe that 0, 1, and 2, but 0 is connected to 2, and 2 has the same color as 0, so the graph can't be bipartite. We're going to return false, and that's it. So if you want to take a look at the code, it's on the GitHub on the description. I think it's a great idea to put some breakpoints, explore, try to, and then try on your own. This is the best way to learn. And if you want to know the best resources to learn algorithms, also take a look at the description that I have recorded a great video where I go into that. So hope to see you guys soon. I have a whole playlist on graphs.